Welcome to this AKIT seminar. This is the third seminar this year, and I'm presenting this seminar. My name is Carl Huang. I am currently the director for the Center for Culture and Technology and also the director for Curtin Open Knowledge Initiative. I've been at Curtin since 2018. Previously worked in University of Cape Town and University of KwaZulu-Natal in South Africa. And I've only just this year taken on these two leadership roles, so still kind of learning my way around things. I'm giving this talk today titled "Who Gets to Cite My Work?" and moving on from citation counting to citation diversity. There's a QR code on there that takes you to the slides. So just quickly an outline for the talk. So I want to spend maybe the first 10 minutes talking about just COCI and COCI data, because that forms the foundation of the core of the work I want to talk about today. And also, I thought it might be good to refresh people's memory if you already know about COCI, what COCI is about and what data we have. And also, for people who don't know about COCI, it's a good introduction to show you what the data is. So that could lead to more users of the data. And then the core of the talk today is about citation counting and citation diversity. And then lastly, there's some discussions about further work that I want to kind of highlight. So firstly, let's talk about COCI and COCI data. So COCI stands for Curtin Open Knowledge Initiative, and it's established in 2018. Now, interestingly, it was born out of frustration of researchers, actually, because it was at a time that a lot of universities were focused on things like university rankings, which we know from literature only tells one side of the story of what university is about, but it do have various implications about how universities work. When we started the COCI, we wanted to find out ways of how we can change that or bring at least awareness of these things, these concepts. So it's a collaboration between CCAT and Curtin Institute for Data Science. I think that used to be called CIC, Curtin Institute for Computation. And so at the same time, there was a lot of push for open science and open access at that around that time. And I guess what we really were concerned with was something a little bit more broader than just access to research. We wanted to have something more broader, and that's why we talk about open knowledge. So we're not only focused on access to research output, but also who actually get to make the knowledge. So basically, we're concerned with diversity of both knowledge creation, but also knowledge dissemination. And we wanted to know how those ideas can come together for universities, and what data do we have, for example, to help universities to support such an agenda. And so that's kind of how we started. And in 2018, to get that going, we also brought together a whole bunch of experts around the world, kind of locked ourselves up in a regional area in Perth, and we together thought about what open knowledge means for universities. And we wrote a book together called Open Knowledge Institutions, Reinventing Universities. Again, there's a QR code to the book if you're interested in looking at that. And that was in 2018. And in 2019, we also had another workshop in Mauritius on the Curtin Mauritius campus, where we formed the coalition of open knowledge institutions. So through those processes and events, it became more clear what our goals were as a project. on the screen, you see that that's the quote of what our goal is. It's to change the stories that universities tell about themselves, placing open knowledge at the heart of the narrative. And we do this by providing trusted analysis, high quality information, resources, and through leading the research agenda on future of knowledge institutions. So it's quite a long sentence, but or paragraph, but basically what we wanted to focus on was how we're able to support universities to think about themselves differently and tell different stories about themselves rather than just focusing on things like university rankings. Through the years, we had many different partners and funders and collaborators, including, for example, CWTS. We together released the open edition of the Leiden University Rankings. We also worked with UNESCO. Currently, we're working on with UNESCO to produce the next Open Science report, and various other partners and funders and collaborators. And this is kind of like a quick timeline of what happened to Koki. So in 2018, that's when we started. We were really working with small files, CSV files, and writing scripts. So a lot of manual work and small scale studies. And we started collaborating with CIDS, and that's when we started expanding our capacity of being able to handle large data. And so in 2019, we started using cloud server through Google, and started then talking about automating a lot of the processes to get the data into a workflow, and then started to increasing our project capacity and complexity. And so there's a bit of data there about, or statistics about what we have. So close to the end of last year, we had data for more than 150 million unique DOI, so digital object identifiers, so basically 150 million research outputs. And that is significantly more than what's held in Scopus and Web of Science. And obviously that was end of last year, so now we have even more than that. And last year, we also became a preferred supplier for the Australian government on research evaluation and research evaluation and bibliometrics. And that's also when the open edition of the Leiden rankings was released. And last year, we also released the Koki Open Access Dashboard, which I'll show you just now as well. So just a quick timeline overview of Koki. And the underlying data. So this forms the core of a lot of our work at Koki, right? So we have, as I said, more than 150 million outputs, and various other, this combines various different data sources, including things like Crossref, which is a registry for DOIs, RAW, which is a registry for research organizations. We also have OpenLX, which is one of the core databases, which gives you information about research output, for example, the authors and references and citations, and all of those metadata about research output. And we also have paywalled, which tells you about open access status and where research here can be accessed from. And also ORCID, which a lot of you will be familiar with, which is the Open Researcher and Creator ID, which is kind of like a persistent identifier for researchers or researcher profiles. And of course, this is not the only data sources. There are a whole bunch of other data sources that we ingest as well, like OpenAir, Open Citations, and so on. And to give you a glimpse of what the data actually looks like, so this is actually a screenshot of our data, actually one of our data tables in Google BigQuery. So this is the core data set, which is we often refer to in a team as the DOI table. So basically, you can imagine this like a spreadsheet, right? You got a whole bunch of rows and a whole bunch of columns. Each row is related to one research output. And you can see the first column there is the DOIs. So that's the DOI associated with that particular publication. And then you got thousands of columns, which consist of metadata, a whole bunch of different metadata about those outputs. So things like which year it was published, which dates, who published the output, where it's published, which journal. We even have some information about things like who's funded the research and what the acknowledgements were like, and which papers these outputs cited themselves. So it's a vast amount of information. You can imagine more than 150 million rows times thousands of columns. It's not something that you can handle on a personal computer. So it's definitely big data, large data. But this actually forms the core of a lot of our work because this gives us a lot of power to what we can actually do. So this is the open access dashboard I talked about earlier. So this was released last year and it's open online. And basically it's open access information about all the countries and all the institutions around the world. So in fact, it contains 225 countries and more than 52,000 institutions around the world. And for each of those profiles, you can basically click into the profiles and look at what's the proportion of open access outputs that country or institution produced, and also look at trends over time and all of those things. So this is at a global scale, but because the way we structure our data, we use identifiers, which is a very important thing, and open data, of course, is getting better and better. This is what enables this kind of work, but we can also not just do things at global scale, we can also do things at a national scale. So this one here is what you call the RISE dashboard, standing for Research Impact Evaluation System, which Rebecca is currently deep into at the moment. And so, so basically what this dashboard does is replicate what used to be called the ERA process, Excellence in Research Australia. It used to be our national research evaluation process. It used to be a process that takes a lot of time and effort, a lot of money for different universities to put the data together into one process and one system so that we can look at how universities are performing. But what we've done with our data, because the way we structure our data, the amount of data we have, and what we could do is take the guidelines from those ERAs and actually reproduce it using an automated process. So those of you that are interested, then can go into the QR code there and look at the demo version of this. And of course, we can go even more local. So, so we can also, for example, do something like this. This is what we've done last year for the humanities faculty. What you did is you took our data in Koki and mapped it against the university's data on researchers. And then we were able to extract all the outputs that are affiliated to our faculty and look at our performance over time and outputs across the different schools, different areas, and how much open access output we have, for example, across the different schools. So this is all enabled by the data that we got in the background, and of course also enable us to think about things differently. And this is the core thing we want to talk about. We'll come back to this. For example, thinking about how we can think about citations differently from what we traditionally do to citations. So as I mentioned, the core of a lot of our work is because of the data and because we're using persistent identifiers so we got persistent identifiers for output, we got persistent identifiers for researchers, we got persistent identifiers for institutions, and so on. That allows us or enables us to do a different project, different types of analysis that are perhaps unprecedented from before. And also open data is getting better very rapidly. As you saw just now in the numbers, it now has taken over the commercial databases in terms of coverage, and the quality of the data is also getting better and better. So that is now enabling us to do open science with open data, open source, open systems, and so on. And I think this is a process that's very powerful because it's more open, it's more equitable. It's also give us more control as to thinking about or having the flexibility to think about how we want to be measured and what do we want to measure about research. This is a recently released framework by the ARC, kind of like a replacement for the old ERA process. And you can see this is kind of like a good signal of how things are changing, because the ARC, this new ARC framework talks about persistent identifiers, it talks about open data, it talks about open access, fair data principles, whereas in the past, a lot of these type of national evaluation systems and also university rankings are really based on commercial databases like Web of Science and Scopus, and you can see this is a real signal of how things are now changing, which is very important. This is just a page to give you a QR code on the various dashboards that Koki have done in the past. If you're interested, you can go into some of these and play around and see whether you find things that might be useful for your own research, and I'll be happy to chat to people about possible ways we can use the data to help people's research. Okay, so then we get to the core of the thing we want to discuss. So citation counting versus citation diversity. So as I mentioned, the data we got in Koki allows us to think about a lot of things differently. And one thing is the citations. So what is a citation? So very rough and broad definition. When a citation is when a research output references or cites another research output. So just very simplified definition of what a citation is. So if you publish a paper, for example, you got your list of references. If a paper appears, another paper appears in your reference list, that means your paper is citing that paper. So it's just that simple. So now, the first kind of like a citation database was created by Eugene Garfield in 1961, so going long time back. But that was a very niche set of journals and publications. Of course, things have changed quite a lot since then. That has obviously, so Science Citation Index has flown into what's now Web of Science, which consists of still the Science Citation Index, but various other indices as well. And with Scopus, that forms the two big commercial databases for such data, for citation data. Of course, now we have a whole bunch of other data sources that are more open, like OpenLX, but then there are also other things like dimensions and lengths and so on. So there's a whole bunch of different databases for citations. And traditionally, we think of citations as a way of quantifying impact. Right? So basically, count number of citations each paper gets and think of that as a way of measuring the impact of their publication. And this use has flown into various things like university rankings, various national research evaluation processes, and even in academic promotions. Right? So I have seen academic promotion guidelines where it actually says you need to actually state what is your H index, for example. Well, that's kind of like a very quick overview of what citation is and how it's been used. Now, typically we count citations in a way, basically just as in how many papers actually cite the work. So, for example, if you look at that diagram, you've got to think of the document on the left-hand side as the published article or the target output that we is concerned with, and then the three blue ones are the ones that cite that paper. So then the number of citations for the document on the left is 3. Right? So that's very, very simple. Now there are various extensions of that idea. So there are things, for example, what you call CNCI, which is quite often talked about at a university levels, which is basically a normalized or standardized citation count. So basically, you take the citation count of a paper and normalize it against what would be expected for the field, for example. And you also have things like H index. So if you have a Google profile, you would have an H index. Google Scholar profile, you will have an H index, which is basically something like, for example, if you have 3 papers that are all cited 3 or more times, then you have an H index of 3. And then you also have things called a journal impact factor, which is basically how many times papers in the journals on average get cited. So these are some of the common ones we see around in the research space. And now, even though these are different variations of the citation count, they are still all, in essence, counting number of citations. It's just counting citations for a group of things or counting citations and then normalize it against another count, kind of. So in essence, all of these, we are still just counting number of citations. And how does that relate to open access? So for a long time, open access advocate has been claiming that open access attracts more citations. So open access output receives more citations. And there's a lot of research and debate around whether that is completely true. And it actually depends on what data you use to do the analysis, what field you're analyzing, for which journals you're analyzing, and those can give you slightly different answers. And this graph actually comes from our own data, the Koki data, and you got those 3 colored lines, which are 3 different versions or 3 different types of open access. So red is the just general open access. So if your output is available online somewhere, it falls in that category. The yellow one or the gold one is if it's available from a publisher website, and the green one is when it's available from an open access repository. So for our own data, and this is at a global scale, you can see that all 3 of the open access categories have higher average citation counts than the closed category, which is the gray one. You can see the gradual decrease is just because paper that published a long time ago would have gathered more citations compared to paper that's published last year would have very little time to gather citations. So that is just a natural process of how citations are gathered over time. So, but anyway, for any of the years over time, we can see that open access have higher count of citations. Of course, that's as I mentioned, that's at a global scale, but at local scale, if you use different data sets for different subsets of the data, it might get slightly different results. And that's why there's been a debate for a long time about whether there's actual impact of open access overall. But what we want to do or what the data enable us, the Koki data enable us to do is think about this slightly differently. Right? Instead of talking about more citations, we can ask things like, does that actually mean more people from more places get to access the research or to use the research? Maybe not, because you could have a higher number of citations, but those citations might all come from the same people or the same researchers, rather than reaching more researchers out there from different places. So we want a different way of thinking about, or different way of measuring the impact through citations. And if you think about more generally about open knowledge and open access, what you really want to do is not just have more citations. What we're actually interested in do is we want to be able to say that open access reaches more people in more places. That we want to increase the diversity of communities that use and benefit from the research, and not just having more citation counts. So we want a way of signaling that to tell us whether that is something that open access gives us. So these diagrams here now kind of want to demonstrate the idea. So, for example, on the right-hand side, left-hand side, so, we got two papers, paper A and paper B. They are both cited by two other papers. So those three blue ones. So that means paper A and paper B both have a citation count of 2. However, if we dig a little bit deeper and we go to say who actually are affiliated to those papers, so you might have different institutions affiliated to these papers, and if you count those institutions and which countries they come from, you see a slightly different story. So paper A and paper B in the diagram, they both have citation count of 2, but paper A is actually cited by more institutions, by 5 institutions through those 2 citing papers, whereas paper B is only cited by 2 institutions, right? So that by going one step further, it tells us a very different story. And then also, if you count number of countries, paper A is cited by 3 countries, where paper B is only cited by 1 country. So using this process, now we can think about where the citations actually come from in terms of institutions, instead of in terms of countries, in terms of regions, subregions, and so on. Paper C and paper D is another example, but having bigger numbers now, so a little bit more complex. But again, paper C and paper D both have 5 citations, but they have different numbers of citing institutions, different numbers of citing countries, and then these 2 are diversity indexes, which I'll talk about just now as well. And they have, if you use those numbers, you can actually calculate those diversity indices and give you different numbers. So the idea here is basically what you can see is that paper C and paper D both have more citations, but paper C actually reaches more institutions and more countries. We can go there now and, well, actually start counting. What is the number of institutions that cite a particular paper? And we can group those together at a global scale. And again, we see that for all the open access categories, on average, get more unique number of citing institutions. And we get the same result for countries, subregions, and regions. But now again, returning to our that graph shows the countries, subregions, and regions. Now, but there is a slight problem here, because again, we're still just counting. We're counting, instead of counting citations, we're counting number of institutions, we're counting number of countries, and so on, which doesn't, again, tell you the full picture. Because, for example, you could have 2 papers that are both cited by 3 institutions, but you could have, for example, this case where it's mostly cited by 1 institution and the other 2 institutions only cite that paper once, compared to the case on the left-hand side, that where all 3 institutions cite the paper equally. So in both of those cases, they have the same number of citing institutions, but actually the spread of the citation is different. And in terms of diversity, what we want is the one on the left-hand side, which is more kind of like the perfect scenario where the reach is equal across different citing actors. So what you want to do is actually have some kind of measure, not just counting number of citations, but actually having a way of measuring that spread of the citations or citation links. Now, we're not going to go into the detailed mathematics, but both of these are kind of like very common diversity measures that are used in the literature, coming from economics and coming from biology, for example. So the first one's called the Gini-Simpson index, the other one's called the Shannon index, but both of them, what they do is they measure diversity. So basically what they both do is they put things into buckets. You have all of these different citation links, you put them into buckets. If the buckets have a good spread or good distribution, equals distribution of the numbers in them, then you get a higher score. If the buckets are very biased, so you have one bucket with a big number, where the other bucket numbers are small, then you get a lower score. So basically that gives us a measure of diversity in both of those cases. So the Jenny-Simpsons range between 0 and 1. The other one, the Shannon index, ranges from 0 and above. So using those now, we can actually go and calculate the diversity measure for every single output, and then take the average, for example, or look at the distribution. So this is a snapshot of 2019 for global output, but for random samples. So we took a random sample of each of the categories of the open access categories. We got 10,000 for each of them, and looked at the distribution of scores, or the Gini-Simpson index score we got for each category. And you can see for all three of the open access categories, you can see the median, which is the middle line, is higher than the closed category, and also even the distribution for each of those three are slightly higher compared to the closed category. So this is showing us that the open access categories have a higher diversity of citations with respect to, in this case, countries. And we can do the same thing for, obviously, for institutions, for subregions and regions.
Citation diversity. It's Carl Wang. ACAT, that's what I'm doing.
Sorry. So we can do the same thing, and this time for Shannon index, but for institutions, countries, subregions, and regions. And you can see in all of the cases, even though there's some interactions between the open access categories, in all of the cases you see that open access categories perform better than the closed category. And we can actually, well, if you don't believe just those 4 pictures, we can expand that to many different other analyses.
I just responded to it, so this one. I responded to it, the one above that. That's just a old school meeting.
Sorry, someone online, the mic.
Can you please mute your microphones? I think it's
Cool.
just the person.
Thank you. All good? What we tried to do in this particular research, or this paper that we published, was we actually went down the route of trying very hard to actually find exceptions of this pattern of the open access output or categories performing better than the closed categories or the closed category. And we did a whole bunch of different things, right? So those same plots, the box plots, and we got the plot all the time. We also did various other types of analysis, including distributional analysis and a whole bunch of complex analysis to try to find exceptions to that pattern. And in fact, in the end, we found very few. In almost all the cases that we have sliced and diced the data, including breaking the data down to different fields, different countries, and all of those things, there were very few exceptions. So, in fact, there's with the publication, there's 127 pages of supplementary material that have all of those graphs. And if you go through that, you actually see there's very, very few exceptions of the pattern. So what you actually have is a very strong and convincing evidence that open access is associated with higher diversity of incoming citations with respect to institutions, countries, subregions, and regions for every year since 2010. So, and that is actually a quite powerful statement, because in the past, we have only been able to say, oh, get more citations. Open access possibly gives you more citations. But this is actually saying not only we give open access get more citations, it actually reaches a wider audience out there, not just more citations from the same people. So this is something that's really powerful in terms of advocating for open access. Now, there are a few streams of further work that I want to highlight. So the first one is not only can we look at diversity of citations across institutions, countries, regions, and subregions, we can also do that for fields. So we can actually categorize those citations or those citing papers into different fields, or fields of research. So what you'll see there, and this is the output that came out from that. So you can actually see that open access categories, in most cases, are more multidisciplinary in the sense that they get citations from more fields of research, right? Including citations from outside their own fields. So that's an ongoing research that we will have to take on a little bit deeper to look at how those things change across different fields. And you can see there are some interesting patterns here, for example, with the gold. Actually, if you go back to earlier years, it drops below the close, which is a little bit interesting and something worth diving a little bit deeper to look at. It could actually just be the data, because if you go back further years, the data quality might not be as good as the data quality for the more recent years, but something worth diving into. And then another thing that we noticed from our analysis was that, so what we have is, we're referring to this as open citation diversity advantage. So basically, open access output get more citation diversity. So it's an advantage for open access compared to closed output. But what we noticed is that that advantage or that benefit is not equally distributed to output coming from different places. So it's a little bit hard to read these diagrams, but this one here on the left-hand side is the percentage change in total citations. So what you see here on the top is the citations to output coming from Northern Europe and citations to that from Eastern Asia, Northern Europe, and Sub-Saharan Africa. And you see what happened is for open access output, since these are all positive, it means there's a positive change moving from closed to open. And that means basically what the idea is when you move from closed to open output, your citations go up. And that's those are publications from Northern Europe, so the citations coming from Eastern Asia goes up to citations to Northern Europe, right? And also citations from themselves to themselves also go up, and citations from Sub-Saharan Africa also goes up, and actually quite a lot. But whereas if you compare to the bottom one, this is publications from Sub-Saharan Africa, but having citations coming from those three regions. And you can see the impact is not as big as Northern Europe. And in fact, you can see, if you compare this last one, it's a little bit interesting because Northern Europe, after you move from closed to open, the citation jumps up really big, right? Whereas for Sub-Saharan Africa, even though there is still a positive jump, the jump is much smaller. So you can see the benefit is not equally distributed across the different regions. You can see from those two, Northern Europe actually benefit the most. They benefit from other people citing their papers more, but they also cite themselves much more. So very, very interesting. And they also cite, for example, Sub-Saharan, they of course much more. So very, very interesting. And you can see that similar pattern, but this is over time. So this is again something that we wanting to dig a little bit deeper and look at why there is such a difference between, even though in general there's benefit for all the different regions and sub-regions and countries, but why is there an uneven distribution of the size of that benefit? And then we also have this one here, which is also, this is actually a question that came about with one of my previous presentations about this work. And someone asked about, we got the gold and the green open access. What is driving the change or the benefit of open access? Is it through gold or is it through green? So what we did here was actually we took the gold open access and broke it down into two parts, because gold and green can overlap, right? Because you can have a output that's available through your publisher, but it's also available through a repository, right? Maybe different versions of the work, but still available through both. So they can overlap. So what we did here is we took the gold open access and broke it down to separate parts. The ones that are only gold versus the one that's gold and green. So what we've done there is then what that allows us to do is look at whether that benefit of publishing open access is driven mostly by what happens when you break it down to just gold and just part that's gold and green. So you can see is that green? The green line is the one that's gold and green, which is higher than the one that's gold but not green. So this is a strong evidence of showing that the repositories actually have a stronger effect. And this is what we saw overall as well in the original analysis. But this is again something worth diving a little bit deeper. And this actually has implications because the question that came about was actually the university repositories wanting to know whether they should still deposit research into the repository, even if it's available on the publisher website. Okay, so then another idea was talking about the citing actors. So we got the countries, institutions, regions. The way we do the calculation, the diversity measures, we were kind of treating all the countries and all the regions as equally important and put them into the measure. But what you could do is extend that to what happens if you believe the citing actors to be different. For example, if you publish a paper that's related to Africa, for example, then having citations from African researchers might be considered more important than citations coming from other places. So you might want to build that into the workflow for calculating those diversity measures and looking at the citation diversity in a little bit more of a flexibility in terms of how you want to calculate that score. Do you weigh some of the citing actors slightly differently? And then the last one is, of course, we don't just have to talk about citations. We can also talk about co-authorship. Because what you can do is you take the papers, the output, and look at the affiliated authors and look at where the authors come from. The institutions they're affiliated with, the countries they're affiliated with, the regions and subregions, and we can do the same kind of calculation on those. And this is just a very rough analysis that shows that open access outputs have a higher diversity of authors. So the one on the left-hand side shows the unique number of authors, and then the one on the right shows the Gini Simpson's index of authors by country. So very, very interesting. Again, something to dive a little bit deeper into as well. Right, so just to quickly summarize what we did. So we talked about Koki data, and the highlight there was that open data is rapidly improving, and that combined with persistent identifiers enables us to do much more complex analysis and also ask maybe more important questions, like how we use citations to measure impact. And then we looked at citation diversity, and we show that open access output receives more diverse citations. And that leads to more broadly new ways to think about traditional metrics like citations to make them more meaningful and useful. And I think that's it. Thank you.